Okay, welcome to section 1.2. Hopefully you've completed all your homework for 1.1. And 1.2 we're going to just be going into fractions and how we use them in algebra. Um, this may be a refresher for some of you that haven't seen fractions in a while. But it's very important that you remember and follow these rules. They'll really help you out as we go along. The first example is going to be just converting we call this a mixed fraction right here into an improper fraction. I see the book has a method for showing you. I'm going to show you something a little different, and this is a nice little trick to remember. Anytime you see a mixed fraction, go ahead and just put a little times sign right there, and then a little plus sign. Every single time this will work. And then to compute the actual value of your improper fraction, all we need to do is say 5. You need to always start in the bottom and go clockwise. 5 times 3 is 15. 15 plus 4 is 19. 19 over just your 5. You don't have to do anything with the denominator. So your answer there is just 19 over 5. Now here's a case where we have to convert the improper fraction to a mixed number. An improper fraction is a fraction in which our numerator, the top one, is bigger than our denominator, the bottom one. So you can see that 42 is definitely bigger than 5. So this is what we call an improper fraction. Many times you guys have probably used the mixed version throughout much of your math so far. But from now on, you're going to start seeing some changes. Most of the time, you're going to have to and want to work in the improper fraction form. It really helps out to work in improper fraction form pretty much from now until the rest of your math career is finished. So the way we convert the mixed number into an improper fraction is we just simply do division. And the simple way to do that is just do old long division. If you have trouble remembering simple, your division tables and multiplication tables. So now we have 5 divided into 42. We know that 5 goes into 4 0 times. It doesn't go in. So go to the next guy. 5 goes into 42 8 times. 8 times 5 is 40. And we're left with 2. Now instead of putting a remainder 2 or going into decimals, the only thing we have to do now is simply get this remainder, put it as a numerator for our fraction over 5, whatever was over here. So our answer is going to be 8 and 2/5. That's simple. And if you want to check your work, you can simply do the same trick we did up here. Times, and then a plus. 5 times 8 is 40. 40 plus 2 is 42 over 5, and that works out. Next we're going to do is factoring to primes. It's going to be important to factor to primes whenever we're trying to reduce fractions and reduce other numbers. Primes are numbers that don't have any other factors that go into it besides itself and 1. So let's go ahead and think about the things that multiply together to give us 100. And it don't matter what you start off with, you always get the same answer. So just to show you, I'll do it 2 ways. One we know is 10 times 10. Now we see we can break the tens into something. We know 2 times 5 is equal to 10. And we still have the times here from this multiplication. And then again, 10 is 2 times 5. So we got 2 times 5 times 2 times 5. We've broken it down into primes because 2 and 5 do not break down any further. Let's say another one we want to do is 24 or 25 times 4. That also equals 100. We can break 25 down into 5 times 5 times, this times comes from this times, and we know 2 times 2 is equal to 4. So now we get 5 times 5 times 2 times 2, which these two expressions are identical. They're equal. So since they're equal, with multiplication, it doesn't matter the order as long as they're in the same operation. we know they're equivalent. So no matter which one you started off with, you could still get the right prime factors. So either one of these answers will work. Now we're going to reduce fractions. Reduction of fractions is very, very important because it can save you some work from doing some long calculations. Many times we're working on problems where the reduction of fractions makes our calculations so simple that we don't even need a calculator. So 6 divided by 14, or 6/14, is it looks like a pretty hairy number, but we can go ahead and work on that. One way we can do this is we can use factoring, and we can say, okay, what number is a common factor of both of these? And we know it's 2 times 3 equals 6, and 1 times 6. We know that 2 times 7 is equal to 14. So the number they have in common is 2. So we'll say 2 times 3, which is equal to 6. So this is an equivalent statement. And then on the bottom, we know it's 2 times 7. So now we can go ahead and perform a reduction. We see that we have a 2 on top and a 2 on bottom. We can cancel those out, and all we're left with is 3/7. And we know the 3 can't reduce anymore, nor can the 7. So we're left with the reduced fraction of 3/7, which is a whole lot easier to work with than 6/14. Let's go ahead and perform the same type of operation here. 15/75. So things that go into 15 are going to be, things that we can multiply together to get 15 are 3 times 5 or 1 times 15. Things we can multiply together to get 75, there's many, many options. But from a lot of experience, we know that 5 times 15 equals 75. So here's where it's really important to know your multiplication tables. It can really help out. So 1 times 15 over 5 times 15, we see the 15s are in common. They can cancel out, and all we're left with is 1/5, or 1/5. And that doesn't reduce any further, so 1/5 is our answer there. The next one we see, we have 25/11. This is an improper fraction. To reduce it, we're looking again for common factors. What are things that multiply together to give us 25? We of course have 5 times 5 and 25 times 1. What are things that multiply together to give us 11? Well, the only factors that give us 11 are 1 times 11, since 11 is a prime number. Now, since 11 and 1 are the only ones down here, or 1 times 11, and we can choose any combination, 25 times 1 or 5 times 5, we see they have nothing in common. So these do not reduce any further. So this 25/11 is actually our most reduced fraction. In the book, I see they flipped it around. They actually made a little mistake, but the answer here for the reduced fraction is actually 5/11. This last one, we have 11 times 1, as we know is the only thing that goes into 11, and 33 is going to be 11 times 3. We see the 11s are in common. We can cancel those out, and all we're left with is 1/3. And we see that 1/3 is a whole lot easier to work with than 11/33. So here's our answer. Now go ahead and go to section 1.2 and work on exercises that involves examples 1 through 4, and good luck.